Hey, so today we're going to factor ax squared plus bx plus c. Now that's a general form for a quadratic. A and b are the coefficients to my x squared and x term, and c is just our constant. We're going to focus on when our a value is equal to 1. So normally we begin any factoring question by looking for a GCF. However, if a equals 1, there won't be any GCF. So the first step is to always factor our first term, which in this case is our ax squared term. The second step, and this is where most people tend to make their mistake, is factor your constant. Factor the c term that also adds to our b value, or our bx term. And the third and final step is to then put it all together. And when we do that, it should look like two binomials being multiplied by each other. So in our first example, we have 1 for our a, negative 10 for b, and c is 21. So 1, 10, and 21, there's no GCF, so we can go ahead and factor. Ax squared is x times x. Now my c term of 21 has many factors. To multiply to 21 could be 1 and 21, or 3 and 7. However, I needed to add to my bx value, which is negative 10x. Now, another way to multiply to a positive is two negatives. And if I were to add those terms straight across, the ones that add to a negative 10x are right here. So to write my final answer as the product of two binomials, I would pair up x with negative 3, and my other x with my negative 7. And then I can check that by multiplying it out using the distribute property, the box method, or the FOIL method, depending on what your teachers taught you. So if you were to distribute this out, you would come back to the original problem. In our second example here, 5x squared plus 15x plus 10, clearly you can see this is not 1. However, 5, 15, and 10 all have a GCF of 5. So I'm going to put 5 outside my parentheses, and if I divide each of these numbers by 5, I get 1x squared plus 3x plus 2. Now that 5 is very important. It's going to become part of my final answer, so I'm just going to go ahead and bring it on down. The next step is I factor x squared, x times x. And I want to factor my c value 2, and remember that it must multiply to positive 2, but add to be a positive 3. Now 2 is a prime number. The only factors of 2 are 2 and 1, or negative 2 and negative 1. However, being that it must be a positive 3, I know that one's wrong. So x and positive 2 are one of my two binomials, and x and positive 1 is my other. And there is my completely distributed, my completely factored term. But if I were to distribute it, I would come back to my original answer.